Hello. In this assignment, we have built a model of housing prices for California census dataset. So to kickstart a machine learning model, firstly it is essential to prepare the dataset for the algorithm. So we will perform several tasks to establish a good dataset using Python tools in this assignment. So foremost, it is mandatory to set up the environment to work with. So here we are using the collab notebook because it is essential, whereas the setup time is 0 and we can work on it irrespective of the platform we use. So we are using the version of the data set that has been collected based on the data from the 1990 California census. So in this data set, we have information regarding the demography in the district such as population, household, location such as latitude, longitude, and general information. So since these statistics are at the granularity of the district, they correspond to medians. So to download these data sets, we are giving the URL and we have created a Python function. So we are using the packages and we're defining the function and then executing a function call to get the data. So as the downloaded data sets are with the extension as star file format, so we're extracting the data in the CSV file format. Next, we are loading the dataset by using pandas package and we're defining a function. So this head function here, which returns the first 6 rows of the data. So we can see the output that our ocean proximity field has a data type as object. So whereas all other features are numerical features which is encoded as float data type. So we can see that the data set contains 20640 of samples and 9 features, and we have plotted the distribution of the features in the histogram so we can visualize the data. So from these histograms we can see that they have long tails, especially in the median income, total bedrooms, etc. So this will be hard for the algorithms to detect the patterns. So we want to transform to a Gaussian shaped distribution for better results. So one of the pointers here is when the data values are exceeding the capped values, for example, like 0.5 to 15 in this median income attribute, we can eliminate these data from our training as well as in the test data sets when they're exceeding. The next step is to split the data into 80% for training and 20 for test set. So we're using random sampling here to obtain the training set. So it takes different samples when we execute each time. So we are also plotting the histogram here. So by comparing with the previous histogram, although the values in these histograms of the y-axis has been decreased, but still we have the same amount of the distribution with long tails in median incomes, and so on with the other attributes. As we are done with the training set, now we are going to the test set. So we are using a method called stratified sampling method here, uh, so that our goal is to predict the median housing price, so which is independent on the median income. So our test set needs to be good enough, so we are adding an additional column called income category. So in this way we are grouping the median income to create a new column as income, which is a numerical attribute as well. So we are plotting it in the histogram here, and then we can remove the income category. So we are doing this to get a better test set. So now that we have a data sets in hand, we can look into the gain insights. So we have used the training set from the previous step and have plotted it. So we are plotting it by representing based on the population and price, and we are finding the attributes by using a correlation coefficient matrix so that we can pair um, each and every attribute. So our goal is median house value. So we are taking only the necessary and relevant attributes which correlates with it. So we can also play around by introducing new attributes by combining to the existing features as such. So we are doing so like this because by introducing every attributes, it will be a large number which will make our job difficult. So we are doing in this matrix way. So next, we must pre-process the data before feeding into an algorithm. So there are different types as such. So one of the method is the simple imputer. So we are doing a lot of manual work which will um, cause difficulty. So we're using the class as simple imputer from the package. So it will take the median and replace in the missing values. In this way, we can get the good data as well as the ocean proximity, which is a categorical attribute. So we can convert into numerical attribute by again using the classes such as one-hot encoder, ordinal encoder, and so on. So instead of storing in a binary format, the other feature scaling transformation, column transformations, the other different types of methods can be used. So as there are many transformations to perform it in a sequential order, we are using a pipeline. So this pipeline is essential so that we is to avoid any data leakage. In that way, you can pass the transformer to a pipeline and it will always be the cleanest and correct way. As the hardest part is over, now we have created the model using classifiers, that is linear regression and decision tree regression, which has continuous values. So we're giving the few training data to linear and all training data set to decision tree. So by using the root mean square, we can see the quality of predictions and accuracy of these models. So in conclusion, we now understand the data preparation by using different transformation, then automating it using a pipeline, splitting the data into training set and test set. So, and then how to train and evaluate the model for better results and accuracy for the given data set. Thank you.